Hello and welcome to EELE 371, Introduction to Microprocessor Hardware and Software Systems. We also call this course Embedded Systems Design. My name is Brock Lemires and I will be your instructor for this fall semester. In this video, what I'd like to do is give you a welcome to the course and also a little orientation so that after you get done watching this, you can actually start working through the course material. So what I want to talk about today is what this course is all about. Very briefly, we'll go into more details in chapter 1 of the course, but I just want to give you a little touch of what you're actually going to be learning. Then I'm going to give you a little background on myself just because I'll be the voice and the hands and all the videos that you watch. And so sometimes it's good to kind of know who's actually talking to you. And then I want to go through the syllabus and importantly talk about the learning outcomes, the course format. It's going to be a blended delivery this semester, so we need to discuss that. And then talk about the course materials you're going to need and the academic policies, and that means masks. So masks are required, and we'll talk about that in a second. And then I want to walk through the Brightspace course management system, the course website, and show you where everything is and how you're actually going to go through some of the materials and how you access everything. Okay, so what is this course all about? This is Embedded Systems Design, which is a term that refers to the embedded computers that exist in modern electronics. So a lot of times when you think about computers, people think about, their Windows laptop or their Mac laptop or a workstation that you're on. Well, there are a lot of those around, okay? So there's 300 million of those that are created every year on Earth, and they're very obvious what they are. But this course is about learning how a computer works, and the way that we're going to do that is we're going to look at a much smaller computer, which is called an embedded computer, also sometimes called a microcontroller. And so you probably heard of some of these common microcontrollers, things like Arduinos, Raspberry Pis, BeagleBones. There's a whole lot of these things that are out there. And in essence, everything really is just a computer, whether it's running Windows or whether it's a little embedded computer within like a thermostat on your wall. And you can learn about computers using either platform. What we want to do is we want to learn about an embedded computer just because it's an inexpensive and very useful little thing to actually learn about and program while we learn. And so sometimes when you use like a really complicated computer, it's hard to know what's going on because everything's abstracted. So we're going to learn about this little embedded computer. It's a Texas Instrument MSP 430 is what it's called. And you're going to have this little board next to you and you're going to be programming it as we learn about computers. And when you're all done with this, what's going to happen is that you will have a deeper understanding of how a computer is architected, how it actually executes instructions. You will know how to program that computer in assembly and also in C, and you will learn about all the different aspects of a computer, things like interrupts and the stack and data memory and program memory. And then you'll look at some of the peripherals that are included on modern microcontrollers, things like timers and serial interfaces and analog to digital converters. So when you're done, you'll know not only about a computer, but you'll actually have a skill set as a embedded systems designer. So you will be a person, an engineer, who can break out a embedded computer board and actually code something up to accomplish a task. And it turns out that this is a very sought after skill because there's a lot more embedded computers in the world than there are what we call general purpose computers, the ones that run like Windows and Mac. Embedded computers, in fact, are, annually there's like over 30 billion that are created. So it's a very common technology. And so that's kind of what this course is all about. Okay, so next let's talk about who the instructor is. So it's good to have a little bit of knowledge about who the instructor is, their history, their experience, because you're going to be listening to my voice through quite a few YouTube videos, and so it'll just help kind of put everything in context of what I'm talking about. So I was born and raised in Montana, Billings, Montana, West High Bear. And I actually got my electrical engineering degree from Montana State University back in 1998. After that, I went to work for Hewlett-Packard in Colorado Springs, where I worked for 8 years as a R&D engineer, research and development engineer. And what I did there was I developed acquisition systems for test equipment. This test equipment I worked on was logic analyzers. And in that job, what I had to do was I designed printed circuit boards, and I did programmable logic device design, and I designed probing systems, and I designed microcontrollers to kind of control everything. So this class is really a component of what I actually did in industry. And so I have background in this, and I also, after becoming a professor, I kind of do research in this area. So I worked for Hewlett Packard for 8 years, and like most companies do, they'll pay for you to go back and take additional graduate classes. So I ended up chipping away at my master's degree at the University of Colorado in Colorado Springs, and I got that after a couple of years working. And then they asked me, that school asked me to teach some night classes in embedded systems design. So I taught this class, 18 years ago, almost 20 years ago. It was totally different technology, but kind of the same basic concepts of what an embedded systems or what an embedded computer is. And I started teaching there, and I really fell in love with teaching. And so I was kind of in this interesting situation where I loved being an engineer and doing embedded systems design and just doing all the cool stuff like building and testing little electronics. But I also love teaching. And so I thought, well, there's got to be a way to kind of combine these things. And looking around, it was like the professor's job seemed like the best way to do it, because I could split my time amongst embedded systems research and also embedded systems teaching. And so I went back to school, just kind of kept going at the University of Colorado, but at this time at the main campus in Boulder. And I chipped away at my PhD and ended up getting that in 2005. And so I was able to get my master's and PhD while working full time at Hewlett Packard. And then a job opened up at Montana State, and I jumped at the opportunity to come back, and that was almost 15 years ago. So in 2006, I came back, moved back to Bozeman, and started as a professor here. And as part of being a professor, you teach your classes, but you also do research. And so my area of research has evolved into building computer architectures that are optimized for various applications. And the application that I'm currently working on is a radiation tolerant computer for NASA. And so I'm showing you my website right here. You can kind of go down here, and you'll notice that I've authored a few books, one of which you will be using in this class, Embedded Systems Design. But you can kind of go down, and I've listed some of the most recent news articles about some of my research. My team has built a few satellites. There's actually 2 satellites in orbit right now that are circling Earth that are testing this computer technology that we've developed. We've actually sent this to the International Space Station for a year, and we were recently selected to actually demonstrate this computer technology on the moon. So in 2023, MSU will be building a computer that comes out of my research group that's actually going to land on the moon, and we're going to test how well we survive radiation. And so if you kind of want to look through some of this stuff and get a background of what I do, this main page has some news articles. I also recently did a podcast, which is kind of interesting, just talking about like my teaching style. I think it'll become apparent the way that I explain stuff, but I kind of did this podcast, and they were asking a lot about what my approach is to education and how I merge my research into what I do educationally. But anyway, you probably may or may not want to do that after you hear so many hours of me talking. If you go over to this research overview, I give you a little kind of description of what the type of research that I do is, and you'll see some of the missions that I've done. So here's the Lunar Project. We have RadSat is one of the satellites that's in orbit. These are about the size of a loaf of bread. You can see the cat head there. You can see the satellite getting pushed out of the International Space Station and then putting it into orbit recently. We've done some balloon testing of this, and then here's our RadSat G, which has the same thing, size of a loaf of bread. Got the M logo there. Here it is getting pushed out of the space station, and again, and then here is our computer getting tested on the International Space Station. So this has been a really interesting and exciting kind of research project for me. And what's kind of neat about it is that as a professor, you don't do much of the actual design yourself. You just kind of mentor students to do that. And so this project has actually had over 150 students work on it, undergraduates and graduates at all levels over the past 14 years. And so it's just been a blast to kind of do this research. So if you're interested in kind of what my research background is, this is what it's about. And so what's really neat, I think, is this is what I live and breathe for, right? This is what my interest is. I worked in industry doing this type of stuff. I do research in this type of stuff. I've written the book on this type of stuff. So this is really like my area of passion. And so I'm going to have fun, at least. I don't know if you will. So anyway, let's move on to the next thing, which is going to be the syllabus. All right, so here's our syllabus, and this document will be always up to date in Brightspace. I will show you where to get it, but this is kind of where the most important thing in here is probably going to be the schedule, which you're going to want to look at pretty much every day that we have class. So this course description is what I just talked about. Learning outcomes are great because we don't do anything in a class that isn't targeted toward getting you to be able to do something. So in this class, it's essentially every chapter in the book is a specific learning outcome that you will be able to demonstrate that you know how to do something at the end of it. And so it's a skills-based type course here. Okay, my contact information, email lemirs@montana.edu. I'm actually in 316C of Norm Asbjornson Hall. So I'm in the new engineering building. Email is the best way to contact me. We're going to have multiple teaching assistants that are going to help out with the labs and do the grading and be available for help. I'm going to list their information on Brightspace because it changes depending on the types of classes that they're taking and their schedules, okay? All right, now here's the big one. Blended delivery, okay? Due to COVID, we have to socially distance. That means that when you go into a classroom, not all the chairs are available to sit in. And so what MSU has done is they've gone in and they've marked off chairs that you're not allowed to sit in, and it has reduced the capacity of the classrooms. So as a result, all of the students enrolled in this class, we can't fit in the classroom that we've been assigned. So what we're going to do is we're going to do blended delivery, and blended is a term that just means some of the stuff is live, some of it is online. So there's different formats. You could do like every other meeting time, we have half the class come, then the other half comes, and then we could have videos for you to watch when you're not in class. But the way that I designed this class is it's actually designed to be a fully online class, and I'm offering it in the summers as a fully online class. So we have a little bit of an advantage because we're going to take advantage of having classroom space to do help sessions, but we also have the ability to, if you don't want to come to campus for this class, you do not have to. You can do this entire thing online. So here's how this is going to work. All the lectures are YouTube videos and textbook readings. So the textbook, I wrote the textbook. So the textbook was written for this class specifically. Like we designed the class, designed all the learning outcomes, designed the lab exercises. Then I went back and provided and wrote up the textbook so that people had a reference. Then I recorded the YouTube videos on top of the textbook. So you can accomplish the lecture by either watching the YouTube videos or reading or both, whatever works for you. So that's how you're going to do all the lecture material. So you don't come to class for that. We have a classroom in the new engineering building in NAH 137, and we have it Monday, Wednesday, Friday between 12 and 2. We are going to use those times as an open help session for homework and labs. Probably not homework, but mainly the labs. And the way we're going to do this is we're going to split up the class. And if your last name starts with an A to L, you come between 12 and 1. If it's M to Z, you can come between 1 to 2. So you basically have these dedicated blocks where you can come and get help. Now, this room is reserved for us, so as long as I don't close campus, that time is yours. So if you want to be on campus and you want a place to work, you're more than welcome to come to the classroom. You're also more than welcome to not come at all. All the grading that you'll see is the homework is going to be automatically graded multiple choice quizzes in Brightspace. So you don't have to, that's not graded. It's automatically graded, I should say. The labs are all going to be demoed by using screenshots, pictures, and short videos. And you'll upload all those files, and you'll upload your code too. You'll upload all those files to an assignment folder in Brightspace, and then the teaching assistants will grade those. So even if you're live, even if you come to class and you're working on campus, you're still going to upload those videos and files to be graded later. So the people who are grading this, as the instructors grade this, we don't really know whether you're live or whether you came to campus or whether you didn't come to campus. So you can do whatever you want. What I'm gonna guess that there's going to be some students in this class that decide they're just going to do everything online because it works better for their schedule. That's fine. There's going to be some that decide they're coming to these open help sessions and they're going to work during that hour because they want to be on campus and they want to have access to a teaching assistant, even if they don't ask questions. That's fine too. And there are going to be probably the majority are going to be working on this remotely and only come to the help sessions when they need. Whatever you are comfortable with, that will work. In the event that a COVID outbreak happens and we have to shut campus down, the course will just march along using the exact same assignments. Nothing will change except we won't have those open help sessions. Now, that time is dedicated to you. And we're going to have 3 teaching assistants and myself that are available during those 3 2-hour sessions for you. So each student will have access to, Monday, Wednesday, Friday, 1 hour help session. We will have some instructors in the classroom. We will have some instructors on a WebEx session, and the links to the WebEx sessions will be posted on Brightspace. If you need help, and you're on, not on campus, just log into the WebEx session and wait for the instructor to get to you. So we will be available during those times. We are guaranteed that we will be available during those times, okay? We are not guaranteeing that we can be available at other times. That is a pretty significant amount of time during the week. So we have 4 instructors dedicating 6 hours toward open help sessions. So we're guaranteed we're going to be available during these Monday, Wednesday, Friday, 12 to 2 slots, but we might not be available. We can't guarantee we're going to be available at other times. So I say that because I really want you to get used to using these Monday, Wednesday, Friday, 2-hour blocks to work on this course. If you stay up to date with everything and don't fall behind, most students can accomplish this course using just that time. So if as long as you get into a rhythm and get into a flow and don't stay stuck up for long on labs, reach out for help, you can usually accomplish this without, you could call it, I guess, without homework, but you can accomplish this in those 6 hours. So I really want you to think about that and try to embrace that. Here's what I don't want you to do. Decide that during those 2 hours you're going to nap or go to the gym, and then you'll do all your homework at between midnight and 2 in the morning. That doesn't help, because if you get stuck, nobody is around to help you. If you work on this stuff during the times where we're available to help you, you won't stay stuck for very long. So it avoids these horrible situations where you get stuck looking at your code and you're sitting there for 8 hours and you can't figure out what to do, and you're tired and you're hungry and you're just not making progress. So we want to get you into a position where you start recognizing when you get stuck and you reach out for help so that we can keep you moving along. Okay, so this is kind of moving toward this self-regulation of your own learning. Okay, so that's what blended means. All right. Now in order to accomplish this, you have to have 4 things. Computer, obviously. There's no way around it. You have to have a computer. That's it. There's just nothing we can say. If you're working at home, I'm assuming it's a laptop. Doesn't really matter, but you have to have a computer. This course is interesting because it's one of the very few engineering courses where the software runs on Windows, Mac, and Linux. I don't know anything about Mac. I have students that can help with Linux, but if you're using Windows, we have all the support in the world. If you run a Mac, you are probably used to this by now. You're completely on your own, because nobody can help you. All engineering software is designed for Windows these days. It just doesn't run on Mac. So the stuff that does run on Mac, it's kind of a one-off software, but it does work. Students do use it. So good luck with that. All right. Textbook. You need the textbook. Okay. But I am going to provide it to you for free as an ebook. Okay. So when you look at, when you go onto the Brightspace page, you're going to see that you have a link to the book. And here it is. It's provided as a PDF, and I'm the author of it. So let's see, let's scroll through and kind of show you what it looks just like a book. One good thing about an ebook though is everything's hyperlinked. So you have all the table of contents is hyperlinked. And then it also, the bookmarks over here are all done. So you can see over here that you can get a real map to the whole thing. But anyway, you can see, this is everything we're going to do in the book, right? In the class. We're going to march through this book from chapter 1 all the way to chapter 15. And one of the things that you'll learn that you'll see is that this is heavy duty do as you learn. Okay, so we're going to learn about a concept and then we're going to code it up. And so you're going to see these examples in here where they have a keyboard next to them, and that means I want you to plug in your embedded computer board, and I want you to code this up and actually compile it and run it And there's a ton of these in here. There's like hundreds of these in here. And you're going to do every single one of these examples in the book. And the way the course kind of works is we talk about the concept, and then we show you an example program, and then you're usually going to do a lab that covers a few of these example programs. And so, for example, this is on subroutines. I'm going to have you do a couple examples of subroutines and show you how it works, and then you'll do a lab on it. Okay, and so the labs aren't going to just be out of the blue. You're going to be coding along. If we were teaching this class live, the idea would be I would lecture a little bit, and then I would code up these examples. We'd all code together, and then you guys would do the labs on your own. Okay, so we're kind of wanting to do that model. You're going to watch the videos, code along with me, because I do all these videos or I do all these examples in the videos, and then you'll split off and then do your labs on your own. So you'll have a chance to actually do some of the stuff. Okay, so let's see. So that's the book. You're going to need that. If you want to buy the hardcover, they are in the bookstore. Honestly, Amazon usually has the better prices, but this is the hardcover. The ebook is free. We're going to give you that for free. You do have to pay for this because it actually costs money to print this thing in color. But either way that you want to do it. Some people like having a hardcover book. I do actually. But anyway, that's the book part of this thing. All right, let's see here. Then let's see our syllabus. Where did little buddy go? Okay. Third thing you need is a portable kit. Okay, so you're going to do all these labs can be done anywhere on planet Earth. All right, I teach this class in the summer. I have students all over America doing this class. All you need is the computer with the software, the book, and your portable lab kit. Okay, so you are going to check out a portable lab kit, okay? And it's going to come in a box. It has this embedded computer board in it, and it has a few other things in it also. This right here is the Texas Instrument MSP430 FR2355 Launchpad board, and this thing is awesome. Okay, it's really inexpensive. It's like $12 or something if you want to buy your own. We're gonna check you out this kit. You got to return this, so don't leave town with this. Leave town, but at the end of the semester, come back and return this or mail this to us. Okay, so you just plug it with the USB cable. You get power for this thing from your USB port, and then you run your programs, and it has a debugger chip right on here, and you can actually download your programs, and you can step through the programs, and you can see what's going on in memory and all the CPU registers. This thing is really cool, and so this allows us to do all the labs remotely. Also in your kit, you're going to see some things that you will use later on, starting in about chapter 12. You're going to see, we're going to provide you with a little micro servo motor, so we're going to actually be able to move something with the MSP430. And then we're going to give you a real-time clock, a little device right here that basically, as long as it has power, it keeps real time, and so you can pull it and see what the exact time is. And this is going to allow us to demonstrate what we call a serial peripheral called I2C. And then you have some jumper wires in this kit. But you're going to check one of these out, and we'll check them out in the main office. And then at the end of the semester, you check them back in, and life is good. Okay? All right. So that's the third thing. Fourth thing is a camera capable of taking a short video, which today is just a smartphone, okay? Like I said, you're gonna demo all your labs by taking a video of yourself. And so what I like you to do is hey, this is Brock Lemires. I'm doing a demo for lab 5.1. Then you show your screen, you show your board. It's usually involves some sort of blinking light or your interaction where you're pushing a button and it does something. And then you say stop, and then you upload that video to an assignment folder. And that's how we know that you did the lab, okay? And then you're gonna upload other things that we might need, which is we're gonna need the source code, so your main.c, your main.asm. But you need this camera to be able to demo all the labs, okay? So that's gonna be important. All right, prerequisite for this course is logic circuits, so like K-maps and finite state machines. If our class is EELE 261, but if you had an equivalent course in there, that's fine too. And you need to have some prior high-level programming course. So I'm expecting that you have at least done Hello World in C or Python or Java. And we don't do we're not going to go crazy on the programming constructs, but we do use C at the end of this class, and so we need you to be able to understand, how that actually works. Okay, Brightspace will. This is the address for it. If you can't log into Brightspace, there's a help contact information right on the first page, but ecat1.montana.edu. You can just do ecat at Montana. Office hours, I'll post basically my most up-to-date schedule on my website, so go to my personal website. And now we're going to get down into the grading. So homework is 300 points. All the homework is going to be multiple choice quizzes in Brightspace, okay, automatically graded. There's going to be labs, 600 points, or 60% of your score is going to be labs. And you're going to do a couple a week throughout the entire semester. And then we're going to have some projects. We're going to have some design projects. We're going to have some, talk about ethics and decision making, careers and stuff like that. So we'll have kind of these open-ended projects that are going to account for about 10% of your grade. I do straight grading. 90% is an A, 80% is a B. I don't like to give minuses. Sometimes I'll give them a plus, but I don't think the minus system, I think it penalizes people. If you get a 91, you got an A. That's not an A minus. Okay, that's an A. Minuses always drove me nuts, so I don't give them. All right, let's see. Academic policies. So before we jump over and look at Brightspace and the schedule, let's talk about these academic policies, okay? Cheating, right? You can work together, you can help each other, you can discuss everything. Engineering is collaborative. We all work in teams in order to accomplish, tasks. However, in school, we need to know that you're actually doing some of the work. So I want every single person to code their own labs. So even if you're coding in a group, like a couple of you are working together and you're like, how'd you do this? How'd you do that? I want both of you to have a computer, both of you be compiling, both of you plug into your board, both of you run the program and then upload your own file. Okay. So collaboration is cool. Cheating in a class like this is when you upload somebody else's code, right? So you grab their code, put it on your own board, and claim it as yourself. So that's cheating. Multiple choice quizzes, that's where you're like, hey, what'd you get? Like you don't take your friend takes the quiz, and then you get all the answers, and then you plunk them in there. It's pretty obvious, but we're just asking you. This is honor system stuff. I'm not going to be at your house watching you. I'm asking you. You're becoming a professional, so it's time to act professionally, and that's probably the last thing I'll ever say about that. All right, here's the big dog. Masks. MSU has decided, the state of Montana has decided, you are going to wear a mask, okay? If you are on campus and you cannot socially distance, you're going to put this little buddy on, okay? Now, here's how this works. If you're in class or you're in a building, absolutely required, okay? When you walk outside, let me tell you a lot of questions about this. It's really when you can't socially distance, you have to have a mask on. But you can't socially distance on a college campus. There's too many people. So getting in and out of buildings, you can't get 6 feet apart from everybody. So just keep your mask on at all times. The only time you can really ever take this off outside on campus is when you're alone. So just keep it on. Everything's awesome. Whole lot of policies about this. You can read through some of these things. There's a lot of stuff in here that talks about things like, what do you do if a student doesn't wear a mask? How am I supposed to handle this? There's health related things for accommodations for not wearing a mask. So if you have and I'm not supposed to ask you, but if you need some accommodation, that you can contact this Office of Disability Services here at this email or this phone number, and they can work with you. Okay. So we're not going to put a mask on you if it's going to cause you harm. And this class is kind of cool too, because if you can't wear a mask, we can do the class completely remotely. Okay. So it's designed to be fully remote. Now, here's a big one. Universities tend to have this culture where people just keep coming when they're sick. And I know it sucks, because if you're sick, you're going to, you miss class and you fall behind, and the class just marches on. Time doesn't stop just because you're sick. And so when you get sick and you don't come to class, it's like sucks. Okay. And as a result, we tend to always have students and professors that come to work sick. Those days have to end, okay? Because COVID ain't no joke, right? I mean, this is something different than the common cold, where you can spread it a little bit and you can make it through. COVID is serious business here. So we need to change our culture into one that if you're sick and you feel like sick, don't come to campus, okay? Because you might have COVID and it's going to spread like crazy, okay? Check your temperature, if you have it, these are pretty cheap and easy things to do. But we really want to change, just to say it one last time, it's changing the culture. If you don't feel good, don't come to class. Everybody here at MSU knows that COVID is here, and we have prepared our classes to accommodate this. So don't worry about falling behind. We're going to help you figure out something, okay? All right, so now let's start going into the schedule. So I'm alone here, so I'm going to take my mask off. All right, here's the schedule. I suggest you consult this thing every single time you work on this class, because it tells you what you're doing for that week, what you're doing for that day, what assignments are due, and how many points they're with. And here we go. All right, so everything is laid out on a weekly type schedule. Deadlines are always due Wednesday at 2 p.m., okay? In general, a week's activities, so like for week 1, almost always the activities will be due the following Wednesday at 2 p.m. That gives you the full week to do it. Almost everybody will be able to get through during that week. But just in case you wanted to use time on the weekend, you can use time on the weekend. If you get stuck on the weekend, you can come back and access the Monday help session and then following Wednesday help session, and then they will be due. So we give you a lot of time to work through these weekly activities. I suggest don't wait until the very end. It's like work on week 1's activity during the week and only, turn them in later or closer to the deadline if something comes up. The exception to this, so that's how every week is. Week 2, these activities are due the following Wednesday. Week 3, the following Wednesday. The only exception is the first homework assignment. You have the first homework assignment. It's a homework 1.1. It's a short multiple choice quiz. Chapter 1 is only a couple pages. And I want to make sure that you can log into Brightspace and you know how to submit a quiz. So we have our first quiz going to be due the first Wednesday of the semester. So it's Wednesday, the 19th of August at 2 p.m. You have to submit that first quiz. It's also going to get you in the zone of like the type of information and complexity that the homeworks are. Because you might look at this and go, what is happening here? Look how many homeworks there are. I mean, there's a lot of homeworks in here. There's 15 chapters and we have like 3 or 4. I mean, there's like over 50 homework assignments. And you might look at that and just be totally overwhelmed. But these homework problems, they are only designed to make sure that you understand the key concept of what you just learned in the video or the reading. So they're not intense homeworks. They're just kind of to make sure that you did watch the video, you did do the reading, and that you kind of understand the main ones. All the learning really is going to happen in the lab, because you're going to actually be able to apply what you learned in the reading videos and homework to a lab. And so you'll notice right away that the lab is worth a lot more. So lab assignments are like 20 points, 30 points. As we scroll down here, we start looking at, the first couple weeks we go through a lot of chapters because they're relatively short and a lot of review. So like this digital logic basics, that's supposed to be review from your prereq. And so you should be able to do all those without having to review too much. Chapter 2 in the book is a review, so if you need that. And then it's a lot of terminology. So we do cover 3 chapters in week 2, but it's really just about terminology. The first lab is just to make sure that you can install the software and run code that we give you. So it's just to make sure you got the drivers installed. And then the next lab, which is in actually chapter 5, it's where you actually plunk some of the buttons yourself. And after that, starting in chapter 6, you get to develop your own labs from scratch. So then from then on out, it's just, look at this, 3 labs in week 3. And then you have 2 labs in week 4, 2 labs in week 5, 3 labs in week 6. And look at all these labs. And they get more in points because they're more complicated. And it just becomes more and more awesome. And as you can see, as you get down into week 9, we actually program in assembly the entire semester up until the middle of October, and then we switch over to the language C, and in 1 week we are able to do every single thing that we learned in the first 7 weeks in 1 week. Okay, so we show the power of the C language and abstracting everything. And then we wrap it up with serial protocols A to D, and then you wrap it up with a final project. In addition, right in the middle, we have this right around career fair. We're going to have these mini projects. So like things like working on resumes, thinking about designing in the real world or the modern world, ethics and decision making. So we'll have some small little projects for you there. And then the final project is going to be something where we ask you to come up with your own requirements and design something that uses multiple peripherals on the MSB. So that right there is the schedule, and this is what you want to be looking at all the time. Right here, I say when it was last updated, so always take a peek at that just to make sure that if it changed from what the version you have, that you actually are up to date. All right, and finally, let's look at Brightspace. So, ecat.montana.edu, you're going to log in with your net ID and password. Forget your password, click right here. Any issues, you just hit the help button. Once you log in, you're going to see kind of your main screen, and it's going to list all your courses over here on the right. So I have, here's the courses that I'm involved with right now. You'll see this course come up on the first day. You might see an announcement from some classes. I am going to have an announcement in here just to let you know that we're alive and kicking. And then if you click on your course, let's look at, let's look at the fall version here. So I'm going to come into here. So here's our fall version of the course. And here you are. So you see your announcement. I just put this announcement here just to make sure there's something waiting for you when you come in here. So I just show you the cover of the book. You see all your tools across the top. The way that this course is implemented, I give you a link right here that's going to take you to the first content page if you wanted to look at it that way. But let me show you the way that I put everything. Everything in here there's two content areas. So there's content and I have two folders. One is course activities, one is data sheets. Every module, which is a chapter, has its own page. And so this is kind of separated. These pages follow along with every chapter in the book, and they have links to everything. And so let's look at the course information and schedule, for example. So here's a little blurb, little important stuff from the syllabus. Here's my contact information. We have one TA listed so far. The course materials are listed here because they're important. And then here's where you download the book. Okay. I have a little extra credit for you right off the bat since we're going to communicate so many times via email. I have a little professional email etiquette guide that you can get some extra credit right there. And then each content page, you can either click the next arrow or you can go back to content and you can look at all the pages, but you just see there's 15 pages here corresponding to the 15 chapters. And then there's a couple pages on here for the projects. So this is a standard module page. So if we look at this thing, what's going to happen is you have the module, you have a nice little picture, and then you have the learning outcomes for that module. So it's going to tell you what you should be able to do after this chapter. It's going to have then the activities. And so in this first module, there's only one section of the chapter. There's section 1.1, and it's going to have a link to, it's going to say you can read chapter 1 in the textbook and or watch the video, and then you do homework 1.1. And if I look at these, if I click on this link, it's going to take you to YouTube, right? And so you go right out here and a little ad in there, but then it ultimately gets to the video, and here's me. So here's me just yammering away here. Let's see here. Can you hear that? There, we'll do that. And so it's a lot of me just sitting in there talking over here, and there it is. Okay, so YouTube videos. Then if you look at the homework, it's a multiple choice quiz. So when you click on it, you're going to be able to, it's going to take you to the quiz, and you can then attempt the quiz. And so this first quiz has 10 questions, and they're pretty relatively simple, like classify a computer with the following attributes into either general purpose or embedded. So if you read chapter 1, this is a really easy question for you to answer. Okay. All right. Now, if I go back to the content page, why I showed you that was because I link everything on these pages. So for example, this is a YouTube link. So that's usually the way you get to it. This is a link to the quiz. You could also get to those quizzes up here, but you don't have to. Okay. So this is another link to the quiz tools. And then when you come down here to get your lab, you're going to do a lab this week. You click on this and you're going to get a handout. Okay. And it's going to tell you what you do for your lab. And then if you come back here, you have a link to the assignment folder, which is getting lab 1.1, and this is where you're then going to upload your files. So again, all the tools in here, quizzes, assignments, you can get to them from up here, but I do link them in these content pages. Okay, so here's a content page. Let's look at module like 6 as an example. This is more where we have more labs. So we're going to do section 6.1, 2, 3, then a lab. Okay, so homework, lab. Then you can come down here, go homework, lab, then homework, lab. Okay, and then you come in here. Let's go look at module 7 really quick. So then this one is like, oh, this one actually has multiple videos for one section. That's okay. I just broke them up for you. And then a homework, then a lab. Then you're going to do homework, lab, etc., etc. Okay, so that's how you're going to do that. At any given time, you can come into, click on grades, and you'll see your updated grades in here. The only other things that are critical in here are going to be, where's the syllabus? So if you go under course information and syllabus, here's the link to the syllabus. So when you click that syllabus right there, that gives you the up-to-date syllabus, and that's where you can check the schedule. Once we get going with, let me get back to here. Once we get our TAs assigned and we have our WebEx links, if you want help during your help sessions, Monday, Wednesday, Friday, we're going to have these WebEx links under the teaching assistants that are online waiting to help you down here. And so WebEx just has an ongoing room that they can be in, and you just join their room and wait for your turn, and then they help you, and you can show your board and show your code, share your screen, and they'll help you work through it. Okay. And that is it. So now you are ready to actually start on module 1 and start cranking through it. You're going to probably not be able to do the lab without the lab kit, but you'll check that out in the ECE office. And I look forward to working with you this semester. It's going to be an interesting situation. This class, I think, is set up well to do the blended. It's also ready to go online. So at any given moment, if something happens with COVID, we'll just flip online and that's it. But otherwise, good luck this semester, and I look forward to working with you.